Good morning, everyone, especially to our professor, Dr. Raymond Sintos, and to everybody. I hope this will be a wonderful year ahead of us, and I hope that everyone is doing great. Happy New Year to all. So, today I will be presenting the second journal of the topic in special topics in production management. And the title of my topic is Scheduling Techniques, a Comparison of Logic. So, this is actually written by Stephen F. Bolander and Sam G. Taylor. Stephen, just a fun fact about Stephen Bolander, he is actually a professor in the College of Business and the chair of the management department at the Colorado State University. So he teaches courses in operations management and supply chain management. And with Sam Taylor, he is actually a professor in the College of Business at the University of Wyoming, where he teaches courses in operations management and management science. So Dr. Taylor's research interests are in production planning and scheduling systems. So let's go. Just to introduce you to our topic, let me share you the definition of scheduling. So scheduling is the art of planning your activities so that you can achieve your goals and priorities in the time you have available. So time is precious and you should value how to spend it. Okay? When it is done effectively, it helps you get clear on your purpose. It calendars your goals. It allows for prioritization of tasks. It claps back against procrastination, and it saves you money, and it adds contingency time for the unexpected. So these are the things that are very important, that when you are doing scheduling, you will really have to, reap the benefits of the positive things about scheduling. Okay, so let me start this presentation leaving you a quote from Stephen Covey, and the quote says, "The key is not to prioritize, but the key is not to prioritize what's on your schedule, but to schedule your priorities." Okay, so this is a witty quote. It uses a chiasmus to point out the difference or the importance of how something else is done. So in this case, the subject schedules and priorities, and which should be driving the other. Okay, so for you, what is your priority? So let's just try to ponder upon this quote. Okay, so on the journal that is actually presented, okay, there is actually a simple model of the five step manufacturing facility. Okay, so these are the following steps. Okay, so we have the raw material input. Okay, and then it undergoes to process A, which is zero point 0.5 hours or half an hour. Okay, and then we have for the process B, usually it takes around 45 minutes. Okay, and then for process C, it takes around 45 minutes again, and then for process D, it takes an hour to finish, and then for process E, it also takes 30 minutes to finish. So until you reach the finished good. So this is basically a simple process flow of how from a raw material a product is created into a finished good. So it undergoes like 5 different steps. Okay, and these are the process times. Okay, as you can see. Now, a simple model of the 5 manufacturing facility is shown here. Okay, so this model will be used throughout the article to illustrate each technique's scheduling logic. Okay, so using the figure without looking ahead, let's try to provide numerical answers to the following question. Number 1, what is the processing time for each unit? Okay, so as you can see, I have mentioned that already. Respectively, for A, B, C, and D, they have a processing time. Okay, and then what is the cycle time for each unit? Okay, assuming no inventory is allowed between process stages are before stage A and a steady state is reached. Okay, so the cycle time defines how long the unit spends in the sequential process from raw materials release until the unit is available as finished goods item. Okay, and what is the throughput rate? Okay, so it's the output per unit of time. Okay, so let's try to answer the question. What is the total number of hours required to process a product in this simple illustration? So what would be the best answer? So the answer is 3.5 hours. So all in all, in this product or this manufacturing system, if they made a unit of this product, it will take around 3.5 hours. Okay, so these are the different or the 4 different types of scheduling techniques that is actually presented in the journal. Okay, so namely, we have just in time, which is very common, materials requirements planning or MRP, and then we have TOC or the theory of constraints, and the PFS or the process flow scheduling. So each of these scheduling techniques will be discussed later on, and then these are some of these or most of these techniques are actually used by successful companies at the moment. Okay, so let's try to discuss first just in time. So just in time is a demand-driven system whose schedule authorization will be initiated by demand for finished good. Demand may be an actual consumer order or an inventory replenishment order. Okay, so that is just in time, meaning products are created when there is a demand. Okay, so they do not create products because just so that they could have inventory. Okay, so they create products when there is a demand for the product. Okay, so in this illustration, so this is actually a figure that is from the original model and converted into a JIT scheduling. Okay, so in this figure, we will assume that a work in progress unit exists at each of the process stage. So steady state system. Okay, and that no inventory storage is allowed between the process stages. Okay, demand now authorizes process E to produce a unit. Okay, and as process E begins processing, a message is released to process D to replenish the work in progress unit at process E. So that message authorized process D to begin working. The same authorization flows back upstream to subsequently authorize each upstream workstations to produce the next unit or release a raw material unit into the process. So thus, we find a JIT environment, a demand-driven, material-oriented system that follows a reverse flow scheduling logic and sequentially moves through each upstream process stage. Okay? So these are some of the most successful companies that is actually practicing just-in-time systems. So we have, of course, Toyota was the first to implement JIT effectively in 1970, and it's still one of the most successful companies practicing the JIT system. So that's from Japan. Okay, and then we also have Apple. So Apple is a tech giant. It has also leverage JIT principles to make its manufacturing process a success. Okay, so Apple's approach to JIT is different in that they have leveraged their suppliers to achieve the JIT goals. Okay, and then lastly we have McDonald's. So McDonald's is a fast food chain industry, such as McDonald's uses JIT in their inventory to serve their customers on a daily basis. Okay, so these fast food restaurants usually have everything they need on hand, but for example, don't start assembling and making their hamburgers and sundaes until the order has been taken. So they are really demand-driven system. Okay, so they don't make any product that is not needed by the customers. Okay, so let's move on to the next one, which is MRP. So MRP, it is the materials requirements planning. It is a system for calculating the materials and components needed to manufacture a product. It consists of three primary steps. These are the following, no? So taking inventory of the materials and components on hand, identifying which additional ones are needed, and then scheduling their production or purchase. Okay, so MRP is done primarily through specialized softwares. Okay, helps ensure that right inventory is available for the production process exactly when it is needed and at the lowest possible cost. Okay, as such, MRP improves the efficiency, flexibility, and profitability of manufacturing operations. It can make factory workers more productive. It improves product quality, and it maximizes material and labor costs. MRP also helps manufacturers respond more quickly to increase demand for their products and avoid production delays and inventory stackouts that can result in loss of customers, which in turn contributes to revenue growth and stability. Okay, so MRP is widely used by manufacturers and has undeniably been one of the key enablers in growth and wide availability of affordable consumer goods, and consequently has raised a standard of living in most countries. Okay, so this is the flow, okay, of the MRP scheduling based on our model, or the simple model earlier. So as you can see in here, the fundamental logic of MRP system and how it schedules the five process. To begin, it is important to realize that MRP system will identify a fixed lead time for each process. Okay, and then this lead time, the move time, and the WI, or the work in progress wait time for each process. Okay, so thus the lead time for process E might be about 1 day. So this information will be reflected in the bill of materials that will describe the 5-step process needed to manufacture the end items. So with that, it reflects the linkage between the demand and the manufacturing capabilities, and will identify the lot quantities of end items to be built and the due dates for this quantity completion. And detailed MRP scheduling proceeds using the master schedule. So all in all, they have to identify each of the products. Okay, so each of the, I mean, for example, if you are making a cake, no? And then in order for you to make a certain product like a cake, you need to buy the materials, you need to bake the cake. Okay, and then you need to, for example, if you have to put it in an oven, so you have to make sure that all these things, each of this factor, or each of this item, you need to know when are you going to schedule its its availability. Okay, and so that you will have to combine everything to make a certain product. Okay, so let's go on to the 8 benefits of MRP systems for manufacturers. Okay, so we have inventory control. Okay, inventory management is crucial to realizing manufacturing efficiency. MRP systems work with data from the production schedule to determine the exact level and cost of inventory required to meet the demand. Okay, and then we have purchase planning. Okay, so streamlining the production process is also heavily dependent on knowing what is available, what to buy, and when to buy your ingredients or the raw materials. Okay, and then production planning. Okay, so MRP system detects bottlenecks in the production line, okay, caused by scarcity or a reduction of material. So when this happens, the system can reroute production or recommend a reroute of the production of a different product where materials are available. Okay, and then work scheduling. Okay, work scheduling manages active production line time. Okay, predicting the expected yield and the adherence to the production schedule. Okay, and then the fifth one is resource management. So of course, raw materials are the lifeblood of any manufacturing processes. So having control and ready information about raw materials availability and expected yield also gives the manufacturer an idea of other resources to engage in the process. Okay, and then we have data management and documentation. So manufacturing involves the generation, analysis, and presentation of tremendous amount of data. So MRP systems assist manufacturers in handling this information. Okay, and then we have economic purchasing. So what is this? Economic purchasing, this system takes into account the quantity and cost of materials needed, including the cost of shipping, storage, and carrying, to come up with the most economically viable purchase to satisfy demand. Okay, and it is also time saving. So MRP systems are fully automated and required little human intervention. So this saves a lot of labor time otherwise used to do inventory purchases and production management. Okay, so plans are nothing. Okay, planning is everything. So what is that? Okay, so in reality, most plans are rendered useless as almost as soon as they are put in motion. There is still some value in the original plan. However, it defines the goal of or the outcome we desire. So, and that is very important, part of the original plan. So the destination is clear. The reason you're on the journey is the first place. Okay, so planning is really the most important thing here. Okay, plans are nothing because if you are not able to reach or to do it, then it will all be for nothing. So that is why planning is a continuous process, and it's a very important thing that all our manufacturing companies should do. Okay, so let's go to the next slide, which is the theory of constraints. Okay, so theory of constraints, according to Goldratt, he coined this theory as a methodology of identifying the most important limiting factor, or which is called the constraint, that stands in the way of achieving a goal, and then systematically improving that constraint until it is no longer the limiting factor. So in manufacturing, constraint is often referred to as a bottleneck. Okay, so the theory of constraints takes a specific approach to improvement. It hypothesizes that every complex system, including manufacturing processes, consists of multiple linked activities. So one of which acts as a constraint upon the entire system. Okay, so the 5 focusing steps, okay, as a methodology to identifying and eliminating constraints are the following. So this is according to Dr. Goldratt. He emphasizes that these are the 5 focusing steps. We have identifying, and then we have exploit, and then we have subordinate, and then elevate, and then repeat. Okay, so in order for you to identify the constraints, you must be able to follow the 5 focusing steps. Okay, so this is the diagram, okay, of the theory of constraint scheduling based on our simple model earlier. So as you can see, TOC creates a scheduling logic quite different from JIT and MRP. It begins by identifying the constraint, okay, which is our example in the process D. So why do they consider process D as the constraint? Because this is the only step or the only process in the system that takes an hour to finish. Okay, so that they considered it as a constraint. Okay, so to maximize throughput at the constraint is scheduled first. Okay, so they need to prioritize this one because this takes a long time, so they have to do it first. Okay, so they begin by translating demand information, time, quantity into capacity requirements on the constraint. Thus, a constraint schedule that maximizes throughput and best meets customers' due dates is built at process B. So all other schedules upstream and downstream from the constraint are then subordinated to this schedule. Okay, so scheduling downstream from the constraint proceeds quite simply. When materials are produced through the constraint, they are moved to the downstream process, which works if there are materials to work on. Okay, and then materials work priority is on the first come first serve basis. So since the constraint schedule has already incorporated due date requirements, the movement of material to the processes is already in the proper priority sequence. Okay, so TOC can be described as a capacity-oriented system at the constraint and material-oriented system at non-constraints. Okay, so theory of constraints uses a mixed flow scheduling strategy that forward and backward scheduled from the constraint. Okay, so let's go on, and these are the companies that are accustomed in using theory of constraints. So a lot of successful or big companies are actually using this theory of constraints. So like 3M, NASA, Abbott, HP, Colgate, Palmolive, GE, Johnson & Johnson, Kraft, Coca-Cola, GlaxoSmithKline, Ford, Honda, Microsoft, IBM, Nike, Toyota, and Heineken. So all these companies, these are some of the most popular, and there are I think a lot more companies than that is actually accustomed to using theory of constraints. Okay, so let's go on to the last one, which is the process flow scheduling. So what is that? Okay, or PFS, like TOC, begins with the focus on the critical process. Okay, in PFS, the master process is defined as a process that severely affects the company's success if it is not managed well. No? In most cases, this would be a constraining process just like the TOC. But it is possible that quality, for instance, might be more important than capacity considerations. Okay? To master the process, once defined, is scheduled first and linked to demand by transforming demand into master process requirements in order to maximize utilization. So from this point, the process flow scheduling begin to depart from the TOC approach. Okay, so the master process is scheduled using either a processor dominated or material dominated approach. Okay, so a processor dominated approach emphasizes the maximum utilization of the process. Okay, so in this diagram, as we can observe, maximum utilization of the process capacity, whereas the material dominated approach, okay, maximize the utilization of materials. Okay, however, regardless of whether capacity or materials are scheduled first, there is a reconciliation of both capacity upstream and downstream processes. Okay, so a feasible master schedule is created here. Scheduling downstream processes proceed by projecting material movement to the next downstream process, which may process the materials in the same sequence as that received from the upstream process, or it may be by creating a decoupling inventory, process the materials in an alternative sequence. Okay, so process flow scheduling is a constraint-oriented system that does by a stage-by-stage reconciliation of capacity materials, schedules in either reverse or forward direction, and uses either a processor-dominated or material-dominated scheduling approach. Okay? So what are the advantages or the disadvantages of a process flow scheduling? No? So one of the noticeable advantages is that it is a capital intensive approach. Okay, so meaning it uses a high proportion of machinery in relation to workers. As in the case on an assembly line, the advantage of this is that high number of products can roll assembly lines at very low cost. Okay, this is because production can continue at night and over weekends, and also firms can benefit from economies of scale, which should lower the cost per unit of the production. Okay, and then the disadvantage of the process flow scheduling is that it is inflexible. Okay, so that is the main disadvantage. With so much machinery, it is difficult to alter the production process. Okay, this makes production inflexible, and means that all products have to be very similar or standardized and cannot be tailored to individual tastes. Okay, and another disadvantage of this flow production process or scheduling is that the work can be pretty boring for employees, no, involved. Keeping staff motivated is therefore an important issue for the management to address to its employees. Okay, and then we need to compare the systems. Okay, so let's try to identify. So this is system comparison of the 4 scheduling techniques that is actually presented in the journal. So we have the JIT here, we have the materials resources requirements planning, we have theory of constraints, and the PFS. Okay, so as a business grows the scale of its operation, it is often need to change its methods of production to allow greater production capacity. Okay, so in here, okay, as shown in this table, JIT systems tend to work best in stable flow. Okay, as you can see, the products it is stable, and then JIT saves the cost of schedule development, but that doesn't provide forward visibility of material and capacity requirements. So it assumes inexpensive setups, which in turn allow production in any sequence and in small lot sizes. Okay, so it emphasizes material flows, cycle time reductions, and then minimal inventory levels, a reverse flow scheduling strategy to meet demands. As you can see, bottlenecks are not managed by this system, since JIT lines are designed with excess capacity to provide system responsiveness. Okay, next one is MRP. So MRP tends to work best in job shop. Okay, manufacturing environments. Okay, it works well in situations in which the product mix varies. Okay, and temporary capacity bottlenecks embedded within the MRP2 systems. Okay, it does not represent a comparison of theory of constraints or just in time or the process flow scheduling with the entire MRP system. So many companies are using MRP system as a key element of their business planning process, which is very, very helpful. Okay, and then theory of constraints tends to work best in a stable flow, or it could either be on a job shop environment with a single constraining process. Okay, it focuses scheduling attention on the best sequences and lot sizes for the bottleneck process. Okay, the bottleneck is scheduled using a processor dominated strategy. All non-constraints are scheduled material dominated strategy where forward or backward scheduling from the bottleneck. Okay, so theory of constraints minimizes scheduling effort and data requirements by requiring significant data only for the bottleneck constraint. Okay, and lastly, the process flow system tends to work best in a stable flow manufacturing environments in which forward visibility or material and capacity requirements is required, okay, for all the process stages. So it requires inventories to decouple schedules of operations in system with multiple constraints. Schedules are created from the constraining operations by using reverse flow, forward flow, or mixed flow scheduling strategies. So at each production stage, Process flow scheduling can use either a material dominated or process dominated strategy. Okay, so PFS systems require extensive product inventory levels, target minimum inventories, and process data, the process definition, production rates, and target run lengths. Okay, so in conclusion to this article, scheduling system offer the use of many alternatives to choose from when selecting a system for a particular manufacturing application. Okay, so the best system is the one that fits the manufacturing environment in which the system is to be applied. Okay, so making that fit requires the use of understanding the scheduling system's logic. Okay? So as illustrated in this journal, differences do exist between the systems, like the four systems, and by making those differences clear, our example helps the user select the most appropriate scheduling system logic. Okay, so I think that would be all for our journal 2. If you have questions or clarifications, feel free to message me in Facebook or in the messenger, or you can also leave a note or a message in the Google Classroom. And to end this one, I would like to as a class discussion this coming Saturday, I would like to leave these questions for you, for everybody. Okay, so these are for the class. Okay, so number 1, given an opportunity to put up your own manufacturing company, what would you choose, or what kind of company or manufacturing company would you choose, and why would you choose that? Okay, and then number 2, what would be the best scheduling techniques are you going to apply in your company? So it could either be you choose only one, or you could choose a mix of all the techniques that have been discussed. And why do you think this is the best fit with your manufacturing company? Again, thank you everyone for listening. I hope that you learned something today, and I hope to see everyone in our live online class this Saturday. Thank you, and God bless us all.